Hello, ladies and gentlemen. Welcome to Math 20-2, Chapter 2, Section 4, Angle Properties and Polygons, Part 1. Now, the objective today is to generalize using inductive reasoning a rule for the relationship between the sum of the interior angles and the number of sides n in a polygon with or without technology. Now, polygons. Here's a soccer ball, first used in 1970 World Cup. And here's a carbon molecule in a Buckminster fullerene cage. Ooh, often referred to as a buckyball in chemistry. Quite interesting. And notice there's a larger atom on the inside. It's a way to trap heavy metals. Anyway, a little bit of interest for you. Now, here we need to fill in the table. Polygon, number of sides, number of triangles, sum of the measured angles, or the angles measures. So a triangle is three-sided. Number of triangles is 1. Get you color code this. 1 triangle. And the sum of the angles is 180 degrees. Now, a quadrilateral, how many sides? 4-sided. Now, the number of triangles is actually 2. Go diagonal, corner to corner. What do you have? 2 triangles. So you have 2 triangles. And I want to notice, since you got 2 triangles, that's 2 times 180 or 360 degrees. Now there is a pattern forming here. Now, the next, a pentagon, is 5-sided. So choose a point and connect the dots, draw a line, dividing it up in triangles. Now there we go. Yes, you can divide it up into more triangles, but what's the minimum number? 3. So that's 3 triangles. 36, 540 degrees. Okay, so there's a pattern forming here. Now, if you see it, fill in the rest of the table. If not, I'll give you a hand. Here's a hexagon, 6-sided. So choose a corner, start drawing triangles. 1 corner and go all the diagonals. And we have 4 triangles. 4, and that would be 720 degrees. Now you should see the pattern forming. Number of sides, n. Number of triangles is n minus 2. And the sum of the interior angles is 180 degrees times n minus 2. Now that's inductive reasoning. Looking at the data, finding a pattern, making a hypothesis. Now, if this hypothesis holds up, this should be 5. This should be 6. Now, 720 plus 180 is 900 degrees. 1080. So we should have 5 in a heptagon and 6 triangles in an octagon. So here's a heptagon, 7-sided. Choose a point. One, 2, 3, 4, 5 triangles. And 5 times 180 is 900. And so it's holding up. So octagon, let's do one more. Octa, 8-sided. So I choose a point, and I connect dots. 1, 2, 3, 4, 5. 1, 2, 3. Yes, 6 triangles. It's holding up. So here we go. I'm going kind of fast, I know. I'm excited when I can prove mathy stuff. Now you are supposed to use a protractor. No, you poopy head, stop that. All right. There we go. So now we have a formula for the sum of the angles. And if you remember that, now if you don't believe me, grab your protractor and measure this angle and 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 this angle, and it will add to be, that was a hexagon, should be 720 degrees. Right. Now, that's what I need you to be able to do. Now moving on, A floor tiler designs custom floors using tiles in the shape of regular polygons. Can the tiler use congruent regular octagons and congruent squares to tile a floor if they have the same side length? Well, I don't know, but fortunately with the computer, I can go 6, 7. I'm able to choose, well, sorry, I was able to choose 8-sided, 5, 6. Oh, you poopy head. They've got to modify this. Goody. Gotta love that. Anyway, so, doing it the hard way. So I take an 8-sided. That's a horrible 8-sided one. Oh, yeah, sorry. Here we go. There's a proper 8-sided. That's an octagon. Copy. Edit. Paste. So. I go like this. Edit. Paste. Edit. Paste. Edit. Paste. So. I go like this. Yes, I can. I have the nice little square there. Now, if you're in class, this is where I'd be handing out octagons and squares and having you cut out and trying to make a tile. So here I have to do it with computers. Now, yes, you can. Okay? Now, if you're the ones in class here playing with these, you're going to go, oh, wait a minute. There's always somebody that goes, oh, you poopy head. It goes like this. Come on. Yes, you can. Oh, come on. Ooh. I can go like this. Oh, you poopy head. Come on. There we go. So offhand, I can come up with 2 different ways to do this. You'll notice you got squares in the middle. Now, it's not the nicest job, but you do get the idea. So you see, there's at least 2 ways to do this. Nice. Now, moving on. Can a tiling pattern be created using regular hexagons and equilateral triangles that have the same side length? Okay. So hexagons are 6-sided. And equilateral triangles. Oh, you poopy head, stop that. Sorry. Smidge smaller. There we go. Now, can I use these? I honestly don't know. But here's where we have a little fun trying. Now, come on, you can do it. Yes, you can. There we go. Now, if you're in class, I give you a bunch of these to play with. And, oh, you poopy head. And you try to make some sort of shape out of them. Now, can you make a tile pattern using these? Well, I think you can. Same side length. So yes, you can. There we go. So yes. Now, is it the nicest, neatest pattern? No, but if you're in class, I would give you a bunch of these, and you can cut them out and go, oh yeah, it does work. Right? So, one time having a little artistic talent makes me jealous of you. Anyway, that's what I need you to be able to do. Now, notice there's not a lot of measurements and calculations yet. Wait for it. All right. Now, if you have any questions, shoot me an email. Otherwise, good luck. Go on to the next video, please.